Hello, hi everyone. I'm Sri, and this is my project for research methodologies. So I have been working on something called StoryNet, coming to the motivation and significance. Um, the idea behind the project is to create a dynamic knowledge base and create a tool for people to interact with the database pertaining to cybersecurity or any other technology, and deepen the understandings and social implications through question generation and question answering. So the knowledge graph here, the data here consists of that I am dealing with consists of the cyber attacks in cybersecurity, and the data is mainly about the natural language articles and reports that are available through CVE, common vulnerabilities, and um, uh, the some kind of attacks dataset, and the National Vulnerability Database (NVD). So the data that I'd like to show you is CV has this kind of data. If you see, the data consists of JSON files which have a description and all the metadata pertaining to the details, more details about what it corresponds to, what this attacks corresponds to. And KC is another data set which also has a similar kind of structure. It is more verbose. So having taken the data from these two data sets and also from Wikipedia and news articles, the architecture looks something like this. The data is used to is fed into a model. It's a ontology based cyber intelligence model that is created on the basis of the taxonomy and ontology that we have come up with using the 5W plus H approach that we are using. And it is also fed with models like the data is also fed to the BERT based Albert and transformer transformer models, and any query that is run on the data using either is answered using either the ontology or the BERT or T5 based model. So the approach goes something like querying the data using using the deep learning techniques which have been developed on the BERT based model. Well, one of them is Albert. Let me show you the setup that I have for that. So the Albert model has been trained. This is the training that data that I have used. The Albert model is being trained for almost thousands of iterations, around 12,000 of iterations, with large amounts of data, and it was able to answer questions for based upon the given context um, and the sample question that you can see here. So this is the Albert model. It is a light version of the BERT that kind of let me we have like we'll discuss more about that in the coming slides. So here I want to just update the approach that we have taken, which kind of uses 5Ws like what, when, where, how, and why. And the idea is to build an interactive game to guide the students through virtual rooms and challenges using something called Minecraft, which will also see in the coming slides. So this is a sample taxonomy that uh, that is a a kind of a tool to that allows us to query the data for better results. And the knowledge graph looks something like this. This has been made using identifying the topics first. So the topics look something like this. Let me show. Okay, so here are kind of sample topics that you can see. So these are the word clouds for the same topics. So the words showing the words that they're composed of, and this LDA for the topics. This is for the CV based data, and the same is here for the KC based data. So these are the topics that have been identified and have been put into the database knowledge graph along with the relations between them that are generated from uh, the identification, the topic identification followed by relation identification, and those can be queried upon using ciphertext, which is a querying language for graph-based database, and I'm using Neo4j to store the nodes of the topics and also the relations between them. So this is the more kind of systematic approach that I've taken to answer the queries. Um, the other approach is using deep learning. The topic modeling pipeline looks something like this that we have just discussed about. So I have used LDA and BERT to identify like BERT identifies the embeddings, creates the embeddings that are used with LDA to identify the topics. So those topics are generated like using autoencoder. Those topics have been identified and are generated that actually kind of creates well, separated topics for each document. Coming to the question generation, deep learning is used here to generate the questions to sort of understand more about the data. So as you can see here, T5 is a transformer, and when used along with the word sense disambiguation, it kind of understands if we are talking about the game called cricket or kind of annoying creature called cricket, and kinds of come up with situation based questions that are apt for given context. And this is a kind of example that I ran across from the data set that I have shown you before. And this is the architecture of the T5 transformer model that utilizes the transformers to generate the questions. So coming to the question answering, like I've shown you before, the Albert training. This Albert is similar to the BERT architecture that we have seen. But the number of parameters is far less, and this is how it performs. And for the measures part, like I have used something called F1 score and the normalized pointwise mutual information NPMI score and cosine similarity uh, along with the sliding window. So that is considered as a good metric to identify the relevance of both the topics. So for the topics, I have considered coherent score. The highest coherent, the number of topics that give the highest coherent score have been chosen, and that those are used to identify like what are the actual topics, and that is being compared to like the existing state of the art models, and it gave a very good comparison, like very good results. So the application looks something like this. The data is fed into the deep learning models, and the ontology is extracted. That is stored in as a knowledge graph, and using Neo4j and for teach. And The front end is going to be the APIs are written in Node.js and React.js, which will be utilized by Minecraft to create a world. So this is a graph that shows like a base level idea about the knowledge graph for the showing nodes and entities and the relations between them. So this kind of acts as a to browse the knowledge base. This kind of acts as a tool to browse the database. So the future work looks something like extending this idea to create the worlds themselves instead of relying upon like just the programmatic way of generating the worlds from the questions. Right now we are generating only questions, but the same idea can be extended to generate the worlds as we have seen in the from the research at Microsoft and Facebook. So we can also automate the world generation and interaction, and connecting to IoT devices makes it possible to integrate Minecraft with real world and show real world effects to the um, real world responses to the activities performed inside Minecraft, like a virtual world. So that concludes my presentation. I hope you I hope it makes sense, and I hope you like it. Thank you.